Okay, here we got the notes for the complex plane. So the complex plane is just a way of plotting complex numbers. So we have two axes like the regular coordinate plane. So remember, a regular coordinate plane has y vertically, x horizontally. However, on the complex plane, the horizontal axis plots real numbers, and the vertical axis plots the imaginary numbers, so real versus imaginary. So if you use both of them, you can get your numbers plotted. The modulus is the distance a complex number lies from the origin, sometimes represented by these absolute value bars, but this is the equation. And we'll talk about why that is when we get there. So first one here, plot the complex number -6 plus 2i. So -6, remember the complex number, this part is the real component, this part is the imaginary component. So if we have a real axis and our imaginary axis, the value here without the I tells us how to move on the real. The coefficient on the I tells us how to move on the imaginary. So -6 plus 2i is -6 on the real axis, 2 on the imaginary axis, which gives us that point there. So essentially, the coefficients act like an ordered pair if you want to think about in terms of plotting x comma y. So a comma b would be plotting like the point -6 comma 2. It's the coefficient, so when you're plotting, you're ignoring the I. Okay, so second one here, 9 minus 3i. So that's like plotting the point 9, -3. So over 9, down 3. All right, so find the modulus. So actually this one down here is the same as this. So we'll talk about what we're talking about. So the modulus is the distance from the origin. So it's the length of that line segment. But we can draw a right triangle where this is A and that's B. This is then C. And Pythagorean theorem says that that's true. So if I solve for C, which is what the modulus is, I do that by taking the square root of both sides. And then you have your formula. So essentially in each case, you're finding the length of the hypotenuse. So for this one, it's the square root of 9 squared plus -3 squared. So that's root 81 plus 9, root 90, which would be 3 root 10. So in this one, square root of -1 squared plus -2 squared. So that's the square root of 1 plus 4, or root 5. 0 plus 6i. Sometimes you'll see this just written as 6i, no 0, but the a value is 0. So the square root of 0 squared plus 6 squared, 0 plus 36. Square root of 36 would be 6, which makes sense. This is just on the imaginary axis, so it is 6 steps away from the center. 6i is just right here. So it's a straight line, just count up 6 boxes. And our last one, the square root of -1 squared plus 6 squared. 1 plus 36 is root 37, which does not simplify. So there are your moduluses. Now this one, what I did was a factor tree. That's 3 and 30, 3 and 10, 2 and 5. So a pair of 3's gives me the 3 outside, multiply the 2 and the 5 back together to give me the 10. The rest of these don't simplify, so I don't have to worry about the factor trees. But that is the end of the section.